Questions for quiz 3 for Math 251. I gave you 3 different functions here and asked you to find the derivative of one of the 3 using the definition of the derivative. The problem with me asking the question this way is I need to write up the solutions for all 3 of them. Now, what are you going to do? All right, so definition of the derivative tells you that f for some function f of x, f prime of a is equal to the limit as x approaches a of f of x minus f of a divided by x minus a. So using that as kind of a blueprint, I can figure out f prime of a down here and say f prime of a is equal to the limit as x approaches a of f of x, which is x squared minus 4x, minus f of a, which is a squared minus 4a, and all that gets divided by x minus a. Note the parentheses here. I want to subtract all of f of a. And to evaluate this limit, well, I can't just change all the x's into a's or I divide by 0. So what I'll have to do is cancel out this x minus a down in the denominator. Kind of the trick for doing that is to group terms. So rewrite things. So you got x squared minus a squared divided by x minus a. And then you got, I don't know, maybe, how should I write this? You got that plus negative 4x plus 4a divided by x minus a. So I took the x squared and the plus a squared, the minus a squared, and put those over here. And then I got the negative 4x and the plus 4a and put those over here. And the reason it helps to write it like that is because each of those 2 fractions can be simplified. X squared minus a squared is the same as x minus a over x plus a over x minus a. And then negative 4x plus 4a is the same as negative 4 times x minus a. And by factoring out a negative 4, I now have an x minus a on the top and the bottom I can cancel. By factoring this as a difference of squares, I have an x minus a on the top and the bottom that I can cancel. So finally, I can say this is the limit as x approaches a of x plus a minus 4. And I can evaluate this limit and just change all the x's into a's, and I get that this is equal to a plus a minus 4. In other words, 2a minus 4. Third of the way done with the first part. Good Lord. G prime of a is equal to g of x, the square root of 2 minus x, minus g of a, the square root of 2 minus a, divided by x minus a. The trick for getting rid of the square roots is to multiply the top and the bottom by the... Shoot, I'm being lazy. Should write the limits in here. I'll go back and do it. G prime of a is equal to the limit as x approaches a of g of x, which is the square root of 2 minus x, minus g of a, the square root of 2 minus a, divided by x minus a. And what the trick here will be is I'm going to multiply, I don't even know how I'm going to write this. Well, maybe I can just write it and you can follow the steps. I'm going to multiply the top and the bottom of this fraction by the conjugate of the numerator, by the square root of 2 minus x plus the square root of 2 minus a. Why am I going to do that? All right, I think I have to write that out. I was going to try to skip that step, but I think that's a bad idea. So I just copied the exact same thing I had on the line above. Grab a different color here. I'm going to multiply the top and the bottom by the square root of 2 minus x plus the square root of 2 minus a, the conjugate of the top. And the reason you do that is because when you FOIL out the top, when you multiply things up top, the stuff cancels really nicely. 2 minus x times 2 minus x, square root of 2 minus x times the square root of 2 minus x is just 2 minus x. The outer terms, that product, and the inner terms are the exact same except one's negative, so they cancel out. And then the last, I got negative times a positive is a negative, and 2 minus a square root times 2 minus a square root is just 2 minus a. And down on the bottom, I got x minus a times square root of 2 minus x plus the square root of 2 minus a. So what happens here is I got 2 minus 2, those cancel out, and so I got negative x minus negative a. Up top, I just have, how about negative x minus a. The 2 and the negative 2 cancel out, so I have negative x plus a, which if I factor out a negative 1, I get the negative of x minus a. And the reason I want to factor out the negative 1 is because it's the x minus a down in the bottom here that I want to cancel out. So now I have one up top to cancel it with. Those cancel, and I get that this is equal to the limit as x approaches a of negative 1 divided by the square root of 2 minus x plus the square root of 2 minus a. This is a limit I can evaluate. I can change all the x's into a's and get negative 1 over 2 minus a plus 2 minus a, both of them square roots, so I have 2 of these square roots. 2 of these 2 minus a things. So right here would be my final answer. Okay, and then finally the last one. Do this in black maybe. H prime of a. H of x is 1 over x, so if I'm going to use the definition of the derivative, I get this is the limit as x approaches a of 1 over x squared minus 1 over a squared divided by x minus a. I got fractions inside fractions. The trick there is to make this a single fraction and then multiply by the reciprocal. So let's see what I can do here. The limit as x approaches a of, if I multiply this side by a squared over a squared and this side by x squared over x squared, I'll have a squared minus x squared, all divided by that common denominator of a squared times x squared. And then that whole thing will be divided by x minus a, which I'll write as x minus a over 1, so that's a fraction over a fraction. And so I can clean that up. I can say that's the limit as x approaches a of the top, a squared minus x squared. Now I'm going to do it now. A squared minus x squared is the difference of squares. So I'm going to write it as a minus x times a plus x. And that's getting divided by a squared x squared. And I'll multiply that by 1 over x minus a. I got an a minus x and an x minus a, really close. I wish I could cancel those out. They're not quite the same. But what you can do is you can change a minus x into x minus a by factoring out a negative 1. So we could say this is the limit as x approaches a of the negative 1 that's left over when I change this into x minus a. But then these cancel out. So I have the negative of a plus x divided by a squared times x squared. That's a limit that I can evaluate. Change all the x's into a's, and I get negative 2a divided by a squared times a squared, which is a to the 4th power. And if you want, you could simplify that. That's negative 2 over a cubed if you cancel this a and one of these a's here. Wow. It's a lot of work. Although I guess you only have to do a third of this work. You don't have to figure it out all 3 ways. But there's the 3 ways you could have figured this out. Now I'm going to do that again. Find those exact same answers, except I'm going to use the definition of the derivative. Wish I had made this quiz different. The limit as h approaches 0, this is the definition. I guess I should write it all up. F prime of a, I wonder if I wrote that up here. Yeah, f prime of a equals g, okay, look at me. F prime of a equals the limit as h approaches 0 of, maybe I should write this somewhere, the difference quotient tells me that f prime of a is the limit as h approaches 0 of f of a plus h minus f of a divided by h. Can you read that? I can't. Let's try again. F of a plus h minus f of a divided by h. Okay, so using that formula and the function x squared minus 4x, I get that f prime of a is the limit as h approaches 0 of a plus h squared instead of x squared. What did I say? Minus 4x. So minus 4 times a plus h. This right here is f of a plus h. And from that I want to subtract f of a, which is a squared minus 4a. Then I want to divide that whole thing by h. It better be an h in the numerator that I can cancel this h in the denominator. In order to see it, I'll expand everything out. A plus h squared, write my limits, is a squared plus 2ah plus h squared. And then if I take the negative 4 and distribute it through, I get negative 4a minus 4h. And then if I take this negative and distribute it through, I get negative a squared plus 4a. And that whole thing is divided by h. And you'll see if you combine like terms, you get the limit as h approaches 0 of a squared and negative a squared cancel out, negative 4a and positive 4a cancel out. I just have 2ah plus h squared minus 4h, all divided by h. Cancel this h with an h that you factor out from all three terms up top, and you get that it's the limit as h approaches 0 of 2a plus h minus 4. You can evaluate this limit. You can change all the h's into zeros and get 2a minus 4 as our answer, which sure enough is exactly what we got right here. What about the next one, g prime of a? Well, that's equal to the limit as h approaches 0 of f of a plus h, I guess g of a plus h. Well, g of x is the square root of 2 minus x, so g of a plus h would be the square root of 2 minus, and then instead of writing x, I'm going to write a plus h. And then from that, I want to subtract the square root of 2 minus a, and I want to divide that entire thing by h. G of a plus h, g of a, h. The trick I'm going to do is I'm going to multiply the top and the bottom by the conjugate of the top. The limit as h approaches 0 of, okay, I'm going to cheat a little bit here. What did I use, purple before? I'm going to multiply up in this step the top and the bottom by the square root of 2 minus a plus h plus the square root of 2 minus a. And by multiplying the top and the bottom by the conjugate, things are going to cancel out pretty nicely. What I'm going to be left with up top is just 2 minus a plus h minus 2 minus a divided by h times this mess, the square root of 2 minus a plus h plus the square root of 2 minus a. But what you'll see is the numerator, things are going to cancel out nicely, as they always do. If I distribute the negative signs through, I get 2 minus a minus h minus 2 plus a. So the 2 and the minus 2 cancel out, the negative a and the plus a cancel out, and all that I'm left with is negative h divided by h over this junk. And now when I cancel out the h's, I get that this is the limit as h approaches 0, which is what this was supposed to say, of negative 1 divided by the square root of 2 minus a plus h plus the square root of 2 minus a. And I can evaluate this limit by changing all the h's into zeros. If I do so, I'd have 2 minus a here and 2 minus a here, each end of the square root sign. So I would have negative 1 divided by 2 of these square root of 2 minus a things. Exactly what I got up here. Finally, I have no idea where I'm going to write this. The last one. Well, I don't have room for it. So how about C, I don't know, h prime of a on next page. You thought I just wasn't going to do it, huh? Yeah, I thought I wasn't going to do it too. But I'm going to do it. H prime of A, I'll figure it out using the definition, or no, using the difference quotient. My function h of x is 1 over x squared. So I would get h prime of A is equal to the limit as h approaches 0 of 1 over a plus h squared minus 1 over a squared. This is h of a plus h. This is h of a divided by h. Fractions inside fractions. You're going to do the same tricks where you want to make it a single fraction divided by another fraction. So you get a common denominator up in the numerator of the big fraction here. My least common denominator will be a squared times a plus h squared. So I'll multiply this side by a squared over a squared and this side by a plus h squared over a plus h squared and get a squared minus a plus h squared divided by a squared times a plus h squared. So that's that common denominator. And that whole thing is divided by h over 1. So I got the limit as h approaches 0 of, if you expand this all out, you would get a squared plus 2ah plus h squared. And so I want a squared minus all that stuff. So what I would be left with is minus 2ah minus h squared, because the a squared and the minus a squared would cancel each other out. And that gets divided by a squared times a plus h squared, and it gets multiplied by 1 over h. Instead of divided by h over 1, I'll make it multiplied by 1 over h. And what maybe you can see here is that there's an h in each term up here in the numerator, so I can factor out an h from each of these terms and cancel it with this term to get that this is the limit as h approaches 0 of negative 2a minus h divided by a squared times a plus h squared. I can evaluate this limit. I can change all these h's into zeros without dividing by 0. What that would leave me with is negative 2a divided by, if this were a 0, I'd have a squared times a squared, which is a to the 4th power, which I can simplify as negative 2 over a cubed, which hopefully is the same answer I got way up here. Oh God, finally done with that problem. That was miserable. Let f be the function pictured below. So I got a graph. Sketch an approximate graph of f prime. So to graph f prime, what I want to do is I want to draw something, and the height of the thing I draw, I want to be equal to the slope of the tangent line to this function right here. So I like to start by finding the zeros. Note that the slope of the tangent line to the function at this point, somewhere in here, would be 0. And it right here would be 0. So the thing I want to draw has to go through those 2 points. The slope of the tangent line out here is a negative number, so the height of the thing I'm going to draw is negative. Note that it's very negative. It's pretty steep here. So I'm going to start out pretty far down here. I'm going to come up. I'm going to hit this point, and then I'm going to turn around. Why are you turning around? Because now this function is increasing. The slope of the tangent line is a positive number. Okay, so I'm not going to turn around. The slope of the tangent line to this function is a positive number, so the height of this thing that I'm drawing should also be positive. Let me draw that a little bit better. What I'm saying is we're going to go right through this point here and keep going up. And how far are you going to keep going up? Well, there's some point somewhere in here. It ends up being the inflection point of this function. But really the key factor about this point right here is it's the spot where this graph stops getting steeper and steeper and starts getting less and less steep. It's still increasing. The thing I'm drawing is above the axis all the way until I get here, because the thing in black is increasing all the way until I get here. But there's some point in here where it kind of starts slowing down. And at that point, I'm going to turn over and start going back down. Go through that. And then what happens? Well, really nothing of interest. It keeps going down. It gets steeper and steeper and steeper. So this keeps going down further and further. I end up with a graph that looks, loosely speaking, like this. And I'll even write approximate. This is f prime. All right, now I want to do a different problem. Now it says, ignore this thing in red right here. Suppose that the thing in black is itself the derivative. It's not the function anymore. It is itself the derivative. So this thing in black is the derivative on what value, on what x values is the function, which I'm calling g, increasing. G is increasing when g prime is positive. But g prime is just the graph up here, this thing in black. This thing in black is positive, well, from negative infinity all the way up to, it looks like -2. Negative infinity up to -2. And then -2, it's at 0, so it's actually not increasing, it's flat for a minute. And that's increasing again all the way from -2 up to 1, 2, 3, it looks like. So my function is increasing from negative infinity to -2 and -2 up to +3. If you included -2, if you just said negative infinity to 3, it's not bad, it's not a big deal. But technically at -2, it's not increasing, it's flat at -2. Because the height of the derivative is 0 right here at -2. On what values is g concave up? G is concave up when the second derivative is positive. Well, I don't have any information about the second derivative, but fortunately I know that the second derivative is positive when the first derivative is increasing. And that's because the second derivative is just the derivative of the first derivative. So since I do have a graph of the first derivative, all I gotta do is look at the graph, the thing in black, and figure out when it's increasing. Well, it looks like it's increasing from this point up to this point. So what is that? -2 up to, I don't know, about 1.5? Again, that's approximate. Those are the x values. And then finally, for what x value does g have a local maximum? It's tempting to be like, oh, right here, there's the local maximum. No, that's the local maximum of the derivative. Right? You want the local maximum of g. This is the derivative. So the way you can find, oh, maybe I'll write this. G has local max when g prime changes from positive to negative. Why is that true? Well, g prime, the derivative, tells me if the function is going up or down. So if the function used to be going up and then stops and now starts coming back down, what that means is at that point where it switched from going up to going down, I have a local maximum. So what I have to do is go look at the graph of g prime, which is provided, it's the thing in black, and figure out when that thing changes from positive to negative. Not when that thing changes from increasing to decreasing, but when that thing changes from positive to negative. That happens right here at x equals 3. To the left of 3, this is above the axis. To the right of 3, this is below the axis. That happens at x equals 3. Mercifully, that is finally the end of this quiz. Sorry for having a, I don't even know, like 20-minute solution video, whatever that is. But hopefully it was beneficial to see all 3 different ways you could have done these, or what you could have chosen for each of these different answers. But I will end this video here.